Chapter 7, Day 7, we are going to work on reviewing the learning targets A through E in preparation for a quiz. So what I'd like you to do, these are all the exponent rules that we've been working on. What I'd like you to do is pause the video and then see how many of these rules you actually remember right now. And then restart the video to listen to the explanation or check your answers. Okay, product of powers, when you have the same base right here, okay, then you are going to add the exponents. So x to the m times x to the n is x to the m plus n, okay? That was one of the first things we learned, okay? But when you have a power raised to a power, it's more powerful. So now what's going to happen is you are going to multiply the exponents. So this is going to be x to the m times n, or just mn power. All right, anything to the 0 power is 1. So the only thing being raised to the 0 power here is this x. Anything to the 0 power is 1. Okay, so an extension of the power to a power is in this next case where you have xy raised to the n power. What happens here is this is multiplied together. And so what has to happen is each of those factors inside has to be raised to the nth power. So now this becomes x to the nth power and y to the nth power. And again, that's because these are ones right here. But if those were numbers or different letters, then you'd have to multiply like in the rule above. All right, let's work on a negative exponent. So negative exponents is you are dividing the base of x that many times. So we are dividing by x n times. So what that becomes then is it becomes 1 over dividing by x n times. So basically negative exponents, if you think about this, could be a fraction, end up being on the opposite side of the fraction as a positive exponent. And so when you have the second example, if x to the negative n is on the bottom of the fraction, now it is going to come up to the top of the fraction and become x to the positive n power. And you could put it over 1, but we don't need that. Then we looked at quotient of powers when we're dividing things with the same base. Again, notice you have the same base right here and you're dividing. So what we do is we are going to subtract the exponents, and this is going to be x to the m minus n power. And if you have the entire fraction raised to that power, again, you need to sort of raise each, the numerator and the denominator, by that power. So this would become x to the n over y to the n. So those are our rules and properties of exponents. So now let's practice some problems. And how I would like you to go about this is you could either pause the video right now and go through all the slides by yourself, or you could just pause the video and work on one at a time, because then what I'm going to do is I'm going to go through explanations. But if you want to just pause the video and go through all of them, you could always check the notes that will be posted with all the answers and the work, and that might be enough. Otherwise, you can come back to the video for the explanations. Okay, in this first example right here, we're simplifying, okay? This piece right here, we look at those numbers just like you would a fraction and we reduce it. So 4 goes into this once, it goes into this 6 times. Okay, since we're dividing, we're going to subtract the exponents. So this becomes 6 to the x 8 minus 3 power. Or what that would become is 6x to the 5th. Of course, this is over 1, but we don't need that, so that is our answer. Next question, okay? Notice we are raising the entire base right here is being raised to that 0 power. So anything raised to the power of 0 is going to have a value of 1. Now, if you had a number on the outside, now that would not all be the total answer. The answer now would be 2 times 1 or 2, but that's not what we have in this case. So let's continue moving forward. All right, now we're simplifying. So again, we are looking at this, and what we have is we have 4 times x to the negative 5. Remember, numbers and letters next to each other means multiplication. So the only thing being raised to that negative 5 power right here is the x. So the 4 is being multiplied with x to the negative 5, which is 1 over x to the positive 5. So now if I multiply these fractions together, that gives me the answer of 4 over x to the 5th. Again, negative exponents go to the opposite side of the fraction and become positive. So using that same strategy, this is going to come up top. And so our answer is going to be 5x to the positive 3. And again, you could put over 1, but we don't need that. So that is our answer. And we showed you originally why that works. That's because this is really 5 divided by x to the negative 3. Well, x to the negative 3 is 1 over x to the 3rd. And when we divide by fractions, we keep, we change, and we flip. And that's why this becomes 5x to the 3rd. Okay, the next question right here. We are raising this entire parenthesis to the 3rd power. So again, we have to take, since these are all just multiplied together, we have to take and raise each of those multiplication factors to the 3rd power. So this becomes 4 raised to the 3rd power times x to the 2nd raised to the 3rd power. And now we're going to multiply those exponents together to get x to the 6th. And then y to the 5th raised to the 3rd power. Again, power to a power is more powerful. So we're going to multiply those exponents to get y to the 15th. Now we don't leave our answer like that because we can still simplify. 4 to the 3rd power is 4 times 4 times 4, which is 64. So we get 64x to the 6th, y to the 15th as our answer. All right, here's another one to simplify. Okay, notice none of these are raised to a power, and all of these are simply just multiplied together. And when we have all multiplication here, then we simply can rearrange things and just multiply what's convenient. And so what's convenient to start with is to multiply these plain old numbers together, and that would give us 3 times 4, or 12. Okay, if I write the x's next to each other, now it would be x to the 2nd times x to the 8th times y to the 6th times y to the 1st. We don't need to do this step, but sometimes it makes it more clear that now what we're doing is we would have 2 x's multiplied with 8 more, or x to the 10th. We'd have 6 multiplied with 1 more, which gives us y to the 7th. All right, now we have a fraction raised to a power. So this entire thing is being raised to the 2nd power. So again, what I need to do is I need to take all of this and raise it to the 2nd power. And then I need to take this and raise it to the 2nd power. So again, applying that distributive property, that's going to give me 3 squared, or 3 raised to the 2nd power, times x to the 4th raised to the 2nd power, or 4 times 2, 8th power. Power to a power we multiply, and then we get over y to the 2nd power. So again, our final answer, 3 to the 2nd is 3 times 3, or 9. X to the 8th, y to the 2nd. All right, so just a reminder about what has happened in the past is, remember, when we add or subtract, okay, we are only adding these coefficients. We have 3 x's and 7 x's, and that gives us a total of 10 x's. When we have negative 2x squareds and 5x squareds added together, that is going to give us 3 of the x squared. Okay, so we don't ever change the exponent power unless we're multiplying or dividing. For adding and subtracting, we can only add or subtract things with like terms. Okay, and our last one here, or this next one here, I should say. Okay, we are taking all of this, raising it to the second power. Again, applying our power properties, that gives us 3 squared, and it gives us x to the 5th raised to the 2nd, which is x to the 10th. So we get 9x to the 10th. All right, so you have a few more questions here to try. And I'm going to go through some of the differences between these. If you notice, all of these look very similar, okay? But it results in different answers. So let's break them down, okay? What we have in this first example is only the x is being raised to the 0 power. So x to the 0 power is 1, but I'm still multiplying that by 12, which gives me 12 times 1, or 12. In this second example, all of this is being raised to the 0 power. So 12x raised to the 0 power is simply 1. And in this question number 3, you are taking this and raising it to the 0 power, which gives you 1, but then you are taking the opposite of that, which gives you a final answer of -1. So all of those look very similar, but you need to be able to distinguish the differences of what's going on. The same is true with question number 4 and 5. So if you look at number 4, it's saying to take the opposite of 6 squared, and 6 squared is 36, and then when I take the opposite of that, that makes it negative. That's different from this problem where it's saying taking -6 and squaring it, which means take -6 times -6, which is positive 36. So again, you need to understand the differences between those questions. And here are a few more problems to try. Now we are actually substituting numbers in for the variables. So since x equals 2, I'm going to put 2 and raise it to the -4 power. Since y is 4 right here, then I put a 4 in for y, so this is going to be 4 to the 3rd power. And z is 10. So if I put a 10 in for z, I get 10 to the 0 power, and I have that original 5. All of these are multiplied together. So now let's take each part separately. This is going to give me 5 times, and 2 to the -4 is 1 over 2 to the +4. Then I have 4 to the 3rd power, which is 64. 4 times 4 is 16, times 4 is 64. And then I have 10 to the 0 power, which is 1. So 2 to the 4th power is 2 times 2 is 4, times 2 is 8, times 2 is 16. So what I have here is I have 5 times 64 all over 16. Now, you can certainly just multiply these together on your calculator. You get 5 times 64, which is 320 over 16. And I believe 16 does go into 320, so now I'm going to divide that by 16, reduce my fraction, and this becomes, excuse me, equal to 20, or 20 over 1. Okay, that was just question number 6. Question number 7, we are not plugging values in for x, y, and z. Okay, we are just simplifying some more. So if I simplify, remember I'm taking all of this and raising it to the third power. So now I'm going to take 2x and raise it to the third power over 3y to the fourth and raise that to the third power. Sometimes writing that intermediate step can be helpful, but you don't need to. And now what you're going to do is distribute that raised to the third power. And this is going to become 2 to the third power times x to the third power over, again distributing that 3 to each of those, 3 to the third power times y to the 4 times 3 12th power. 2 to the third power is 8, so I get 2x to the third over, and 3 times 3 is 9 times 3 is 27, y to the 12th. Okay, notice that I cannot subtract these exponents because x and y are not the same base. Okay, I also cannot reduce the fraction 8/27 because there are no common factors, so that would be my final answer. And I believe these are our last two questions to try and explain. So here I have 3x to the negative 5. Only the x is being raised to the negative 5. So this is going to be 3 times 1 over x to the 5th, okay, or 3 over 1. And then I'm multiplying by 4x squared, which again I have to raise each of those pieces to the second power, which would be 4 squared and x squared. I could put a 1 under that. Now I'm just going to multiply straight across, which is 3 times 4 times 4. So I get 16 times 3, which is 48. Sorry. And then I have x squared, and then over x to the 5th. But notice here I do have the same base, so I need to subtract those exponents, which gives me 48 x to the 2 minus 5, which is negative 3. But I can't have negative exponents in my answer, so this is going to come to the bottom and become 48 over x to the third, and that is your final answer. So don't forget to simplify all the way. And our last problem here to go through, we are raising all of this to the 4th power. So that means we have to raise each of those to the 4th power, 7 to the 4th power, times x to the negative 5 raised to the 4th power, which is going to be the negative 20th power. And then we have y to the 3 times 4, or 12th. And then I'm multiplying all of that with x to the 2nd. And again, this is just times in between, times y to the negative 6. Notice I have a common base of x's, so I have to add those exponents together. So this is going to give me 7 to the 4th power, which is 7 times 7 times 7 times 7, which is going to give me 2,401. And then I have x to the negative 20 plus 2 is going to give me negative 18. And y to the 12 plus negative 6 is going to give me y to the 6. But again, I can't have negative exponents. They go on the bottom. So this is going to be 2,401 y to the 6 over x to the positive 18. All right, so that is the end of our day 7 review of Learning Targets A